Okay, in this module we're going to be looking at polar ecosystems, and we're going to be getting data from a particular site, the Palmer Long-Term Ecological Research Station here. I've got some links here that are going to be relevant for us today. So I'm just going to bring this site up here. This is the site. This is the Palmer Station Antarctic Long-Term Ecosystem Research. This is LTERs, are a series of sites around the world that do long-term ecological research, look at trends in time. We're going to be looking at trends in sea ice, krill, and in penguin populations. And you can see this site here is actually in Antarctica, and here's some views of that. We're going to go over to About and go to Overview, and you can see this is what Palmer Station looks like. It's on Anvers Island. It's resupplied by the LMG. And you guys can read a little bit about what the major questions are here with this system. It's a gorgeous system, really interesting. And you can also go, let's go back here to Research Labs. You can actually do a research overview here, and it gives you a sense for what different parts of the ecosystem that the LTR looks at: physical forcing, ecology, biogeochemistry, all kinds of interesting things like that. But importantly, they have a sampling grid here that also goes along with their actual station work. So most of our data is going to be focused here at Palmer Station, which is near line 600. It's actually station 40, so we'll be looking at data. But they actually collect data up and down the Western Arctic Peninsula. That's this gray thing here. This is the Western Arctic Peninsula, and the actual station here is on this island here called Anvers Island, and that's going to be important for us to remember this geography when we think about some of the data that we're going for. One last thing that you're going to want to take a look at is the actual data set. So if we take a look at data here, can go to the Palmer LTER data catalogs, which is what we're going to be using, and that will bring you here to this what's called an EDI portal, and we're going to be using the EDI portal in order to get our data sets. So one of the main things that you can do is use any term here to search what it is that you want to, any sort of data that you want to bring in. It says download all the results as a CSV. So we've already looked at comma separated values. And so we're going to be looking at relationship between sea ice, krill, and penguins. And so I'm just going to put in sea ice here. It brings up a couple of different examples, and we want to take a look. Let's see, here's average monthly sea ice over the whole system. Here is average yearly sea ice coverage for the Palmer LTR region. So if I click on this, yeah, so we are going to be using, so we can read about this a little bit. This is average yearly sea ice coverage for the Palmer LTR region. Again, that's the Palmer LTR region right there. This is taken by Sharon Stammerjohn at University of Colorado using satellites. We're actually going to be looking at this one here. This is annual sea ice extent. We'll just click on it here. Let's see. Should actually bring down a text file. You can click on the text file and you can see what it says. So this is the annual sea ice extent over open water in kilometers squared for these different areas. There's Anvers Island, Levasier Island, Avian, and Charcot. We are interested mostly in Anvers Island right here. That's what this is here. So this is Anvers Island extent, maybe, and this is Anvers Island area. And so this is the data that we're actually going to be reading in, and you can see it goes from 1979 all the way down to 2020. So let's go ahead and close this. We're going to come back over to our code here. We're going to read in sea ice data. So we're going to be using a function called read.table. This is similar to read.csv, but let's just call this sea ice equals read.table. And now we have to give it a file. And what is that file going to be? Well, we're going to go back to our site right here. This is the one that we were looking at. Pang4, and I'm going to right click on this thing. I'm going to copy the link address, and I'm going to put that in quotes right here. That is the path to that file. And then we also need to do a couple little things here. We're going to say that there's a header, but then we also need to skip some lines. So if we go back and we open that file again that we had open, you'll see that we have to count the number of lines here that we need to skip. So here's our header, and this header, depending on how the file gets read in on your computer, you may need to adjust this line a little bit. Let's go ahead and count here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we need to skip 16 lines before we get to our header. So I'm going to type skip equals 16. And you can do your own counting if that doesn't work. And now let's go ahead and run this. Okay, so now we have this thing called sea ice that we read in, and we can click on it and take a look and see we have year. Here's Anvers Island extent, area, right? These are the other islands over here. Maybe those are interesting for you. We also have minus 999s in here. That turns out to be missing data, so we'll take care of that in just a little bit. We're going to define what we eventually want to do is plot year and average sea ice extent. So let's just go ahead and define a variable called sea ice underscore year. And that's just going to be our sea ice $ year. And what do I mean by $ here? Well, I could do this in a couple different ways. One way I can say sea ice, well, let's just run this for a second. And let's just see what this is. So sea ice year is just a list of years. So if we come back over here, all I said with this notation right here is in my object sea ice, which is this, there's a column name called year. If I do $ and I put that column name in there, R will figure out that this is what we want. Now we could also do, like we did before, bracket column 1, right? So another type of notation that you could get here too, I'll just put it down here, sea ice bracket comma 1. That means we want all the rows, the first column, and if I hit return, I get exactly the same thing. So it's two different ways to get the same kind of data. We're just going to use the name here so we know what it is, because our matrix in this case has these nice names that we can reference. Okay, we're also going to want Anvers ice area. And what is Anvers ice area? Well, we're going to want sea ice. You notice that. And $, what do we want out of sea ice? Not sea ice here, I'm sorry. Sea ice, $. We want the actual area of the sea ice. There we go. So if I run this thing, you'll see that we have these values now. ANV ice area. There they are. There they are. And so that's the same if we take a look at sea ice here, right? So here's our area right here. These are these same values that are in the third column here. Okay, so if you notice in here, we've got some minus 999s, which are missing data, and we're going to have to take care of those because we don't want to plot the minus 999s. It's what's called a data flag. It's a value that the author has told you is no good. So here, you can see this as no data is marked with a value of minus 999. So we need to take care of those. We'll probably turn those into NAs. So let's go ahead and do that. Let's just go ahead and go ANVR ice area equals, we're going to use the replace function. Place ice area where okay, here's the replace function. This is how you read this. I'm going to replace this thing wherever Anvers ice area equals minus 999. So that is in these cells here, this one and this one. Where this is true, I'm going to put an NA in there, or not a number. And so if I run this, oops, should be AND. Apologize. There, you can see now we have our NAs in here. Now let's actually plot this stuff up. Put a note in here, plotting the sea ice for Andrews Island. Let's go ahead and plot sea ice year with and ice area. Type equals L. Okay, let's run this plot. Okay, so here's our sea ice year. Here's our Anvers ice area. You can see that it was high, kind of dropped down, maybe coming up, maybe going down again. And here's where our missing values are. So these would have been minus 999s. It would have been off the chart, but the NAs just show a break in the data, and then the time series continues. So that's a pretty simple plot, but before we make this one look too nice, we're going to go ahead and read in and find some krill data. Let's go ahead and do that. So we've got one part, we got our sea ice. Let's go to reading in krill data. All right. Okay, let's go back to our website, go back to our data set over here, and let's put in zooplankton. This krill are part of the zooplankton, and do a search. Okay, so we have zooplankton collected with a 2 meter, 700 micron net. So it's 2 meters wide with a mesh of 700 microns. So it's going to catch anything bigger than 700 microns. From the surface to 120 meters deep, aboard Palmer Station LTR annual cruises. Okay, this is from 2009 to 2020. We have zooplankton collected aboard Palmer LTR off the western from 1993 to 2008. So this here, this 1998 to 2008, is a time series that comes before this one, 2009 to 2020. So we're going to actually take this data set and this data set together, and we're going to put them together. So this is going to make us put two data sets together. It'll be a little bit of coding, but it's not too bad. So let's start with the early one here. Okay, so here is zooplankton collected aboard Palmer LTR from 93 to 2008. Here it is. Here's a description of the data. And here is the data right here. It's a CSV file. And so again, we're going to go ahead and copy this link address. And let's go ahead and put this link address right here. That's the one that we're going to need. But we have to put a function around this in order to read it in. So first of all, we're reading in krill data from 1993 to 2008. So that's the first one. And then we're going to read in from 2009 to 2020. So let's just call this one krill_1. And we're going to read.csv this thing. Our file equals, we'll put this in a quote like this. So far so good. And I'm just going to put header equals true. So let's go ahead and read this thing in and see what it looks like. Oops, looks like we have an extra comma there that we don't need. Run. Krill1. Okay. Well, this one's big. This is 955 observations of 86 variables. My goodness, that's a lot of variables. So let's go ahead and see what this thing looks like. All right, we have study name, cruise tow, cruise name, event, tow, grid line, grid station, latitude or longitude, and then our heading, speed over ground, water depth, and then we have what? Then we actually have how much she was filtered. Then you have like, yeah, all kinds of things in here. Cnidarians, ctenophores. We got to find krill. But there's so many columns that what we're going to do instead here is we're just going to check out the names of krill. might be a little bit easier. So if we just come down here and just let's do names of krill_1. Let's see if we can pick out what we need. Oh my goodness, okay, here it is. All right, so the things that we're going to need, we're going to need the study name, so we'll need that. We're going to need the grid line, because the grid line, that's that 600 line, so we want to get it near Palmer Station, and our grid station is going to be 40. So again, if we take a look at this, if we remember, let's go back to the website here, and we go to Research Overview. We want, so these are all the places where tows were taken. We want stuff near Palmer Station, which turns out to be line 600, station 40. That's where it is that we're going to be looking at for krill. So if we come back over here and we take a look at our krill1 data set again, here's study name, here's our grid line, we want 600, we want grid station 40, which is, look, the first one here, but there's a whole bunch of them. So we're going to have to pare that down. That shouldn't be a problem. And we want our krill, which turns out to be these guys here, Fausia superba. That's a number. That's a number of krill, Fausia superba. So let's come over here. Let's just say that names krill1, I'll just call this N. And let's see if we can pick out which ones we want. So let's do N. Which elements do we want from N? Well, we probably want number 1, number 6, number 61, and 62. Oops, 62. So this is just a test to see if it gives us what we want. Oh, incorrect number of dimensions. I have to actually concatene these. So we want our study name, grid line, E superba, number, and volume. Oh, we need one other thing. That's right, we're going to need 6 and 7 because that's our station name. Yeah. Okay, so these are the ones that we're really going to want. So I'm just going to put this in here just as a marker. I'm just going to ask for krill1 to be overwritten. I want it to be, I just want those variables. So I'm going to do krill1, I'm sorry, all rows. And what columns do I want? Well, it's going to be the same as these name indices here. So I'm just going to copy this and put this in here. So what this is saying, oops, I have to copy it like this. There we go. So what this is saying is give me everything in krill1, all the rows, and these columns. So I want column 1, 6, 7, 61, and 62. So if I run this again, you'll see that now my krill1 has gone down to 5 variables, and if I click on it, I get the study name, the grid line, the grid station, the number of E superba, and the volume of E superba. And so you might want to work with either one of those. That's up to you. And we really want to focus on just the grid line that is 600 and the grid station that is 40. And so we are going to run a function called subset. So let's just write the function here at first. Maybe let's do question mark subset before we go any further. So what does subset do? You can subset any vector matrix, we have a matrix here, by certain conditions. And so I'll show you how this actually works. So let's go over here to, let's subset krill_1. And what are the conditions? Well, I want to know where krill_1 $ grid line, where is the grid line equal to 600? So if I do that, that's going to return, let's just run this. It's just going to dump all the data here to our screen where the line is only 600. You can see that, right? Grid line's only 600, but now we got to do the same thing with grid station. So we're going to put an AND statement in here, and where krill_1 grid station equals 40. So if I do that, you'll see now all of our data has the grid line 600 and grid station 40. Okay, so we have that data. And here's all our study names. And you'll notice that the actual year of the study is buried in the name. So we're going to deal with that in just a little bit. But we have quite a few here. And we're going to now reassign this to krill 1. So what we did here, right, if we keep track of this, krill 1, we read in this old CSV file. Then we subset it. We overwrote krill 1 here with just these columns from krill 1. Then we're overwriting it again, just subsetting it. And again, if you get confused or you get messed up, you can come back up here to the very top and just rerun all this stuff. And it should give you what you need. There you go. So now if we hit krill 1, we have 23 observations. Remember, we went from like hundreds of observations and, you know, lots of variables to 5. 5 variables, or 5 columns in this case. Everything's at this grid line, grid station, and here's our E superba. So here's a toe in 93, 94, there's 2 in 94, 95, 95, 96, 97, 98, 98, a couple here, only one in 2000, 2001, 2002, all the way down. So almost one per year, but not necessarily. So what we need to do next is we want to combine or average values together that have the same study name. So in this year, they happen to take 2 samples there, and we're just going to average these values together. And that's what's going to serve as our krill estimate for just that year. And so we're going to use a function called aggregate. So I want to aggregate krill underscore 1, and I want to aggregate this by the study name. What function do I want to apply to these? I want to take the mean. And I want it to ignore NAs, if there are any. So if I run this, you'll see that now we've aggregated these together. So now just for every year, we have one, or for every study name, we have one value. We have one value. Now, our study name got turned, is actually over here now in group 1. Our grid lines got messed up, our average of that, the average of that's still the same. So I'm going to reassign this as krill 1. Again, if you get confused on this or things aren't working, try just running it back from reading the file natively. And so now let's take a look at krill 1. That's what this is. There it is. Here's our group. Okay, so now what we have to do is, you'll notice that we need to put our, we have to somehow get year out of this thing. Somehow get year out of it. And so it looks like we go from 2000, 2001, 2002, all the way down to 2008, and then we start at 98, 99, and then we go back to 93, 94, 95, 96. So we're going to go ahead and construct our own year vector here that matches those. Then we'll put them in order later. So let's do this. Let's just call this, actually, you know what? I think I'm going to make this its own thing called ag. So I'm going to come back here to the top and rerun this, just so that we'll keep this thing separate here. This krill ag is now 16 observations of 6 variables. So let's call this our krill 1 aggregate year. This is the year that we're going to put. So we need to make our own vector. And if we take a look at it again, we have to go from 2000 to 2008. Okay. All right, so let's do 2000, comma, colon 2008. That's going to make a vector years. Then what's the next set of years that we have here? Well, we got to go from 98 and 99. Okay, so let's do 1998 through 1999. And the next one is 93, 94, 95, 96, 97. So 93 to 97. 1993 to 1997. So if I run this, we've made a year vector. So I'll just copy this here. You can see here it is. Now we have to attach this to this aggregate function here. So I'm going to use a function called cbind. I'm going to column bind krill 1 ag year 2 krill 1 ag. Column bind these things together. And you'll see that I've just stuck the year now onto this group, and you can see that 2000 here matches 2001. Okay, now we got to call this thing something. And maybe we'll just go back to calling it krill1 again. Okay. Just like that. Okay, and again, if you get confused, something doesn't go right, go back up to the beginning of your code, read it all in, you can copy it down. It will run what it is that you need to run, and then you'll get to krill1. There it is, and you've got your year and your E superba. These are the things that we actually really want to plot. But now we got to put them in order. Because we want to plot them in order. We want to plot them starting in 93 and ending up in 2008. So how are we going to do that? Well, we're going to use a function called order. So if I look at order, krill1, and let's just look at the first column. So what's the first column of krill1? It's those years that we just made. Let's put those in order. Okay, now it didn't put them in order, but it gave me the index to put them in order. So it tells me that, okay, our first year, 1993, right, that's in the 1, 2, 3, 4, 5, 6, 7, 8th position. It really should be in the first position. And so this is how we're going to use order. We're just going to put this, let's just do krill1. And if we put this command, so all this is, I'm taking the output of this index, and I'm putting it in the rows here, and it should put things in order. So let's go ahead and run it and see. There you go. So here's 93, 94, 95, 96, all the way down to 2008. So now we're going to call this thing krill1. So now if we click on krill1, you can see now we've got these years in order. So real quickly, we'll make a really quick plot. Let's go ahead and now plot krill1. I'll just do the first column. That's our year. 1, 2, 3, 4, 5, 6. We need the 6th column. There we go. And this is now our krill that were caught right out in front of Palmer Station over that time period. And maybe let's just do type equals L. Okay, so it looks like it was high, then low, then high, then low, but generally getting lower. Okay, so now what we got to do is actually get our read in krill data from 2009 through 2020. So this is going to be a similar exercise to that we did here, but it'll be shorter because we can copy and paste a lot of this data, or a lot of this code. So let's call this krill_2 read.csv, and let's go back to our website. Okay, so we read this one in from 1993 to 2008, so let's now do this one from 2009 to 2020. It tells you a little bit about it, who took it, the data. It was Debbie Steinberg. And so, right, so here's the description of the data, and we're going to come over here and we are going to copy this link address. That's the data that we're going to download. So we want to read this thing. And it has a header. Let's go ahead and read it in. Okay, so here's our krill 2. Again, here's our cruise name, grid line, grid station, slightly different locations, so we'll have to look where it is a bit, but here's all of the groups that they collected of zooplankton. Again, we're looking for E. superba, which is Antarctic krill. So we'll come down here, and we're going to do something pretty similar. Let's just look at the names of krill _2. There they are, and I'll just tell you, since I've already looked at them, that the ones that we're going to be working with, krill _2, are the same ones that we were before. They're just in slightly different positions. So we're going to do krill 2. 2 is actually, we just want these columns. They are in 2, 5, 6, 83, and 84. So if I run this one, you'll see now krill 2 has cruise name, grid line, grid station, E. superba number, E. superba volume. Same ones that we had before. And we're going to have to do something similar to this, except we're going from, here's 09. All these actually look in order. 10, 11, you know, and so on and so forth. I think it goes all the way down to 20. 2020. Okay, so let's do this. So we got krill 2 here. So just like before, we want to, in fact, I'll just copy this from up here. We're going to use a subset command. Copy this, except we'll make this krill 2. Subset krill 2, where krill 2 grid line is 600, and the station name is 40, so let's run that. So here's krill 2. We're going from 432 observations. Let's run it. Oh, we went to 0 observations. That's no good. So when you mess up like that, come back up here, start again, run, and it could be that I don't have the right names in here. So let's go back and look at krill 2 again. It's grid line, grid station, and I have grid line, grid dot station, just grid station. Let's try this again. There we go. Now we have 21 observations of 5 variables, grid line, grid station, and it looks like we do have some repeated values here for these different cruises, so we're going to run the aggregate function again. So let's come back over here, let's aggregate. This is going to be our krill 2 aggregate, krill 2 by the list, krill 2 study name. Krill 2 has study name. Oh, it's actually cruise name. Okay, so let's change this to cruise name. Mean. Okay, so we'll run this. Krill 2 ag. There it is. Now we got 1 per year, grid station. Here's our E. superba number and volume. There we go. Down to 20. All right, great. So just like we did before, let's go ahead and make a krill 2 year is equal to 2009 to 2020, because that's the order that it came out in. And then, similar to before, let's just go back to krill 2. We're going to cbind our krill 2 year with our krill 2 ag. In fact, let's just do E superba number. Take a look at krill2 ag. Oh, it only goes to 2020. Okay, so this needs to be actually 2020. Let's start again. Come up here. Okay, krill2 ag. Now let's go ahead and take our krill2 is just going to be krill2 year. Let's see, bind these together. krill2 year and our krill2 ag. There it is. There's our year, and there's our now E superba. Now let's just focus on the number here. So we're going to pare these down. So let me just close these out here a second. So here's krill1. You can see that we've got our year and our number here. And here's krill2. We've got our year and our number. And we want to stitch these things together. So let's just come down here and let's just make krill1. It's just going to be krill1. The first column, which is year, and the fifth column, 1, 2, 3, 4, 5, 6, sixth column. And krill2 is going to be krill2. Same thing, 1, 6. Let's check. 1, here's column 1, and then 1, 2, 3, 4, 5, 6. The number of E superba. Yep. So we're going to really pare these down. So when we look at krill1, you can see it's just those two things, and krill2 is just those two things. And so now we're going to put these together. Okay, now that we have our two reduced krill data sets, well, here's krill1, where we've got krill year and the E superba in numbers. Here's krill2. You'll notice that we have slightly different names here for these two, so we need to fix that before we put them together. I'm just going to do this. Let's go ahead and do call names of krill1. If we do that, that will return these two things. And let's just set these equal to C year and krill number of krill. So now if I look at krill1, you'll see that it's year and krill number. And we'll do the same thing here for krill2. And then what we'll do is we'll just come down here and just make a large, just a thing called krill, where we r-bind. We're going to stick these two things together, krill_1 and krill_2. And if we do that, that is going to give us this thing that's just called krill, which is year and krill number. See, all the way down to 2020. So it's a little bit of data massaging to get the data that we wanted, but you can see how it works. And so real quickly now we can just plot krill column 1, krill column 2, and see what that looks like. Okay, good. In fact, I'll just put this up here. Type equals O. So yeah, you can see that we had krill go down and up and down and up, and then it was low for a little while, and then it shot back up again, and then down and up and down, and maybe there's another cycle happening here or something like that. So that's what's going on. Okay, the next thing we're going to do is we're going to read in Delhi Penguin data. So let's go back to our data website here. So our data sets, and let's put in here, okay, let's go ahead and search for penguin now. And the one that we're going to be looking at here, there's a whole bunch of different penguin data that you guys can work with, is Adelie penguin colony-specific chick production. So we want this one, this Adelie penguin adult and chick counts. So let's copy this link address. We'll go ahead and just put it behind a hashtag here. That's the one that we really want. And let's just call this thing pen. Read.csv, quote, put that one right in there, and our header equals true. Go ahead and read that in. Okay, so if we look at pen, we now have, here's again our study name again, with the date, the time. Here's a bunch of different islands that are in the Palmer Station region. And we're going to just sum all those together. And here is the number of adults and the number of chicks at each one of these. So we'll probably just average the number of adults and chicks at any given year. So let's come back here. Let's go ahead and aggregate this penguin data. AgPen. We want to aggregate pen just columns 6 and 7. So it's just these columns here. Here's column, so here's 1, 2, 3, 4, 5, 6, 7. And we want to aggregate that by the study name. We just want an average number of counts, right? Because there's multiple counts during the year. We just want an average number of counts by pen. We want to do it by the study name. And the function that we're going to use is mean, and we're going to ignore our NAs. So if I run this thing, and we look at AgPen, you'll see here is now the study name. This is the average number of adults and the average numbers of chicks that year across all those islands. Now we had to come up with a year vector again, because here's 2001, 2002, 2003, all the way to 2012, 13, 14, 15, 16, 17, 18. Then there's 21, and then there's 92. So we need to come up with a year that makes sense. So let's go ahead and make a pen year, and that is going to be 2001 to 2008. And what comes next? Oops, AgPen. 2001 to 2008. We should go to 2018. Not my mistake. 2018. And then we go to 2021. So it looks like we missed a couple years. So let's do 2021. And then we're going to do 92 through 2000. Penguin year. Okay. So let's just type this again. There it is, 2001. Right, so that's the year. Now we got to put that in order, just like we did before. Well, let's first attach it to our, let's just do ag pen equals cbind pen year ag pen. Okay, so here's our ag pen. Here is our penguin year. There's the number of adults and the number of chicks. And now we got to put these things in order. So we're going to use the same sort of approach we did before with the krill data to put these things in order. So again, order agpen1, what does that do? That's an index for the order of these years, and then it's going to reorder those in agpen in the row side and spit out a new agpen. So if you get confused, you can just come up here, run this stuff again. Okay. There's agpen, and you can see now here's 92 all the way down to 2021, and here's our adults and our chicks. Okay. All right. So far so good. And let's just do a little plot of that real quick. Let's just plot agpen with, should be the first column, agpen. Which one do we want to do from agpen? Maybe the third column for the adults. Okay. See what that looks like. Oh, generally down, maybe ticking up. It's not sure what's happening in these years here, but pretty interesting. Pretty far down with the Adelie penguins, at least the adults. Okay. So the real challenge here now to make sense of our sea ice, our krill, and our penguin data. And so we're going to do that through plotting. So we're going to now plot sea ice, krill, and penguins together. So the main way we're going to do that is through a big panel plot, multiple panels, and we're going to start first by just plotting sea ice and krill together, and then you'll see how we make that into its own little panel, and then we'll add some more plots. So let's go ahead and do that. Let's clear out all these plots. Let's give ourselves a nice big plotting area to do some work here. So let's start here. Let's go ahead and plot sea ice year. Well, what do we have? We have sea ice, right? Sea ice year. And Anver ice area. Type is going to equal L. Let's start with this. And we're going to build it out. Oops, I'm sorry. Anv ice area. Let's make a color here for ice. Let's give it blue. Okay, and maybe a thicker line width. Let's give it a Y label. Our Y lab equals, it's got to be in quotes, sea ice area, and this is in kilometers squared. Okay, and how about an X lab? Year. Okay, so this is the sea ice area and the foraging area. What are we going to do next? We want to put a plot on top of this thing. Here's what we're going to do. Par new equals true. So what we're going to do here is we're going to plot the krill right on top of this plot. So when you do par new true, what that does is that it's just going to add the next plot right on top. And so we're going to plot krill 1, krill 2. Remember, if we take a look at krill 1 is year, krill 2 is krill number. Type equals L. Our line weight equals 3. Our color equals red. So let's throw this on top. Okay, so it threw red on top, but you can see it's a little bit messy. Okay, so one of the main things is you can see that the years start differently. So we're going to make sure that the range of the years on the sea ice is the same as the krill. So I'm just going to start and go back to this, get rid of that thing, and let's give this the plot for the krill, the x limit, the range of sea ice year. So what that's doing is it's taking the krill plot and it's giving the x-lim the same range as the sea ice year. So if we run this now, you'll see that the dates actually line up. Okay, so let's just make the plot, this x-lab for krill equal nothing, and our y-lab for krill equal nothing. Just a space. Let's just run this whole thing again. This. And we have, you can see our axis is no good here, right? It's just getting messed up. So we're going to put the krill axis on this side over here. The way we're going to do that is we're going to do axes equal false in the plot command. We'll run the whole thing again. You'll see that the axis goes away, and then we're going to re-add it. Axis 4. So there's 4 sides to a plot. 1, 2, 3, 4. Axis 4, we'll stick our y-axis on this side. There it is. Okay, so one problem though is that we have a lot more space over here than we do over here. So we need to adjust something that's called par, or the par margin. So we're going to come back up here and we're going to use a par command. And what par does is like another way to handle different aspects of the plot. And we're going to use par mar, which is a function that is going to set the amount of margin space between these different plots. We're going to do 5, 5, 1, 5. What does this mean? This means that you have 5 on the bottom, 5 on the left, 1 on top, and 5 on the side. So when we do that and we run our plot, you'll see that the plot margins change a bit. And we're going to do par new true, and we're going to add this stuff. And you'll see now that we have room over here for our axes label. Now we need to add a label here to this thing. And we're going to use a function called mtext. Mtext is margin text. So if you do question mark mtext, you may want to use this in the future. It asks, what is your text? What side of the plot do you want it on? What line do you want it on? And so the way to think about it is that if you take a look at our plots here, we have 4 sides. It's going to ask what the text is. We're going to put it on side 4, and the line is like, how far away from the plot do you want it? So for this one, we're going to put in, our text is going to equal E suburba per 1,000 meters cubed in foraging area. Okay, we want that. We want the side to equal 4. And maybe we'll try line equals 3. So here's our sea ice, here's our krill, E superba per 1,000 meters cubed in foraging area. Okay, so maybe we make these capitals here. Okay, let's remake this whole plot. Okay, and now we need to add a legend because we got 2 lines on here. So what is our legend going to be? Our legend. Now we need to add a legend. What's our legend going to be? So we want our legend x equals bottom left. X is going to be in the bottom left. And our actual legend is going to be sea ice and krill. Let's go ahead and run that. Okay, sea ice and krill. Now we got to give these things colors. Okay, what else do we want to do for our legend here? Line weight equals 3. Color equals, well, sea ice is blue. And krill is red. And let's do BTY equals no plotting. Let's come up back here and run this from the start. There we go. There's sea ice and krill. Okay. The next one that we want to do is sea ice and penguins and their chicks. We're just going to start here again. I'm going to grab this plot. In fact, we're going to grab from here again. Par equals new true. So now what we're going to do here is this plot here. In fact, I'll just put a note here. This is plot sea ice and krill. This one we're going to plot sea ice and penguin adults and chicks. So we can start here with the one that we already created, sea ice, and now we're going to add to it. Pen year, and ag pen chicks. Put that on top. There's our chicks. You can see that it's messed up, so we're going to go ahead and add a couple of, so we'll just restart this again. And we'll go ahead and add a couple things to it. Type equals L. We want, again, our xlim, just like we had here, the xlim to be the range of our sea ice lab. That's got to go in this plot. There we go. Back up here to plot. There we go. There's our there's our chick data right there. So let's go ahead and make that a little thicker. Type L equals 3. Let's try running that again. There's our penguin chicks. Maybe lines. Pen year. This is going to be adults. Adults. Line weight equals 3. Color equals black. There it is. Okay. So just like before, now we have to add an axis to this. So this will put our, right, 50 to 150, and we need our M text. Borrow this from up here. It's now going to be average number Adelie penguin adults and chicks. There it is. Okay, now we need to add a legend. So we already made a legend up here, so I'm just going to copy this, put this down here. Legend is going to be bottom left again, but now we have sea ice, and now we have Adelie adults and Adelie chicks, and we need this to be blue, black, gray. There we go. Okay, so we might need to adjust things a little bit here, but we can do that when we put this into a big panel plot, and it'll be okay. Okay, so far we've got those plots sea ice, penguin adults, and chicks. And now we're going to do one more plot, which is plot krill and Adelie penguins and chicks. We're going to come up over here and we're going to grab, we already made a krill plot, or this one right here. This is going to be our starting plot, although our axes are going to be true in this case. And our x-lab is going to be year. Our y-lab is going to be, we've already written this, superba. Okay, there we go. And now we want to add the Adelie penguin stuff to this, which is this stuff right here, par new, true. We can just copy all of this. Okay, so now we can just run up from here to plot. You can see we've got the lines on there. Okay, and now we just need to add our legend. Bottom left, we have now krill, Adelie adults, Adelie chicks. Let's change this to red. Run just this section. There, okay, so now we have a couple plots here that are pretty nice. In fact, I'm going to sweep all these old plots out, and I'm just going to come up here to the very top. Not the very top, but where we start to plot these together. You can see we copied a lot of code, run all of that, and you can see we have these three separate plots that we need to put together. So the way that we're going to put these three plots together is we're going to come to the very top up here, and we're going to use a function called layout. What layout does is it's going to break up the plotting area into three separate areas. So we're going to create first a matrix. Our data equals 1 to 3 with number of rows is 3 and the number of columns equals 1. So if we make this matrix and we take a look at it, oh, whoops, this has got to be an equals. You'll see that we've got 1 column and 3 rows in this matrix. When I give that to the layout command, it's going to break up this plot area into 3 separate plots with 1 column of plots. And so I'm going to do layout like this, and you'll see what happens. So the first plot will go in the first upper third, the second plot in the middle third, and the third plot in the lower third. So we'll do that. Now I'm going to come back and I'm just going to run just the sea ice and krill plot. And you'll see it's up here. Boom, boom, boom. Now we have to adjust our labels here a little bit. So let's come in here. Sea ice area. So I'm going to put something that's called a forward N, which is a line break. So let's go ahead and try this again. I'll just sweep this away. Let's go ahead and try from layout down to here. Okay, still didn't quite cut it where I wanted it to. So I'll put this line break like that maybe. There we go. And now we got to make this a line break too. Superba, we'll do, there we go. Okay, let's try and shrink that text. So mtext, let's just do cx equals 0.6. That should shrink that text size down. And if we go to the next plot now, let's just run this part of the plot. you can see that it puts it here. Okay, so that's pretty useful. So we have to adjust this guy. So that would be this one. Sea ice area and penguin foraging area. So I'll put a /n here. And average number of Adelie. I'm going to put a /n here. And I'm also going to shrink the text 6.06. That's a little too small. That's a little tiny thing over here, so I'm going to rerun that. There we go. Okay, looking much better. We need to run the last one. Little texts here, our labels. .6, and this one needs to. Okay, so let's go down here and run the whole thing, starting with layout. Okay, that looks pretty good here. So looks like we could adjust this legend here a little bit because it looks like sea ice, the lines sort of get in the way there. So we'll come here down here to the. In fact, we'll do this for all the legends. We'll just do CEX equals 0.7 maybe. That's just a size parameter, CEX, size of the text. Once we do that, and you can adjust this based on how big your own screen is here. Oh, I have to start with layout, go all the way down. There we go. That's much better. You can see things much, much better. So that brings us to the end of this coding exercise. You can see what's happening here with the krill and the penguins and the sea ice. And of course, when you're done with this, you can go ahead and save this current document. I would save it as like polar ecology, something like that. And you can always export and copy these graphs to your clipboard and to use them in your homeworks. Okay, thank you.